This session is on Spring and big data, so I just want to start out and see how many here are actually working with big data type of applications. All right, quite a few. How many here actually work with Hadoop? And how many of you work with something like Spark or Flink or? All right, so we got a selection. All right, Hive. You got any Hive guys? Okay, a few. All right, so let's kick this off. There we go. So a little bit about me. My name is Thomas Risberg. I work on the Spring data team and Spring Cloud Data Flow team at Pivotal. I've been working on committing on Spring since about 2003, and did co-write some of the Spring data book and Spring framework development book back in 2005. And I'm now working more on the Hadoop and Spring data, big data side, so that's what I'm going to talk about today. Start with talking a little about what I see as big data, and then we're going to talk a little bit about building microservices with Spring Boot and Spring Cloud Stream. And I'll also talk a little bit about different projects we have in the Spring portfolio for working with big data, like Spring Integration Batch and Spring Data Projects, etc. And I run a couple of demos to show how you can get started writing Spring apps, working with big data. So one is the data ingestion app, and then the other one is doing a little bit of data analysis. And of course, we not just want to run this on our local laptop, we want to run it somewhere else, typically in the cloud somewhere. So I talk a little bit about that, how we can get going with that. But first, let's talk a little bit what I see as big data. It's kind of a vague term. You see a lot of different definitions out there what big data is. Some of them is just that you have data sets that are too large to compute with traditional data processing methods, which is that will change over time. Right, next year, whatever, the bigger data won't work with last year's data processing engine, so it like keeps going and going. And I don't know if that's the best definition. I tend to look at it in all the new technologies that pop up, developed by the big internet companies, to work with this stream of data that's just come at us at a faster rate and a larger amounts all the time. So I'm looking at like Kafka, Hadoop, HBase, Cassandra as examples of these type of software projects that try to deal with these issues. And they have something in common. They're all usually open source, and they started at one of these big web companies, either Facebook or Google or somewhere else. And they're written with the intent that they should be able to handle scaling. Since we get more and more data, we need to be able to scale our systems. And they also support more than structured data, they support unstructured data. And you want to be able to handle that efficiently. And in terms of Spring, we'll be talking mostly about boot apps that we write to dealing with big data. And another Spring project that's very useful is Spring Cloud Stream, which makes it easy to deal with streaming data coming in over either Rabbit or Kafka. And then we can handle the data coming in our application. So we don't have to deal with that part of the problem. And it seems like whatever program we write, there are more and more things we have to deal with. So if we have the Spring project that deals with reading from Kafka, I don't have to worry about that. I don't even have to know much about Kafka. I can just implement or import that into my project, and I'm good to go. And for Spring Data, we have the Spring for Apache Hadoop project, and we have another project like Spring Data Cassandra, and we also have the Spring Kafka project. So let's talk a little bit more about the different Spring projects. The one I'm working on mostly is the Spring for Apache Hadoop, but we do have a new project called Spring for Apache Kafka, and if you want to know more about that, there's a talk tomorrow at 11:30. that deals. This is a fairly new project, but it's kind of interesting. And there's the Spring Data Cassandra talk tomorrow as well, so you might want to catch that at 3:20 tomorrow. And also in this category, I would include the Spring Data Gemfire, which is how to write Spring programs against Gemfire, or now the Apache Geode, which is the open source version of that. And again, there's a talk tomorrow, or Thursday at 9 a.m. on the Spring Geode. And there's also a whole lot of new Spring Cloud projects that are interesting in this space. We have the Spring Cloud Stream, I already mentioned that. There's also the Spring Cloud Task, if you want to run jobs up in the cloud or on your local laptop, something that doesn't handle streams, it's just a short-running task. And then we have the Spring Cloud Data Flow, which Mark talked about a little bit earlier today. And that helps us orchestrate all these microservices that we write, or if we just use someone else's microservice. But let's talk about the Spring for Apache Hadoop project a little bit. So it provides extensions to Spring and Spring Boot and Spring Batch, and also Spring integration to help us build robust pipelines around Hadoop. So it provides more of a consistent programming model that we're used to from the Spring environment. So it helps us configure and set up the Hadoop connectivity and different job types. And it does support like MapReduce jobs or running Hadoop tools, Hadoop jars. And also we can distribute the distributed cache in Hadoop using the configuration options if you write a Spring Hadoop job. And we do have like batch tasklets for working with Hive, Pig, HBase, Scoop 2, and also now Spark. And there was a tasklet for MapReduce. So you can run these as part of a Spring Batch job and have a tasklet execute something on Hadoop as part of your Spring Batch workflow. And we also have code to help you write to HDFS, which provides partitioning support, and it makes it a lot easier to actually, you don't have to deal with a low-level HDFS code. You can sort of write your higher-level Spring app, and Spring for Apache Hadoop library will take care of opening and closing the files when they should be closed. And also, we have support if you want to write programs to run on Yarn. So you can submit your jobs run on Yarn with our Yarn programming support, and make it a lot easier. I don't know if any of you have tried writing a Yarn app. It's not the easiest to get going. So Spring makes it a lot easier. And we do rely on this common Spring Framework features like configuration and property files and different environment profiles. If you want to run your code in a test environment, then put it in production. Just apply a different profile. So the important part here is the developer productivity. That's what we're aiming for. We want to create like well-formed applications that are easier to maintain over time. We want to make it simpler to access HDFS. We have an FS shell, which sort of lets you write code in your Spring application context to actually do some scripting, copy files, delete files, create directories, delete directories, so your job can run. Because a lot of times if you're running your job and the directory already exists, it will fail. So if you write a Spring Batch stream or something, and you can actually script the deletion of the output directory. And like I said, we have implementations for running batch flows with Hive and Spark, MapReduce, etc. So what are the use cases that we address? Well, mostly it's ingestion, whether it's reading from a file from JDBC, from some other NoSQL database, and writing it into HDFS. And now with the Spring Cloud Stream, it's very easy to consume events from a stream and persist that data in HDFS, which is what my demo will look at. And also we can go the other way, export data from HDFS to whatever target data source you want to write it to. And again, Spring Integration, Spring Batch helps us make all this possible, and Spring Boot makes it a lot easier to write these kind of apps. And then once we go to deploy these, we can use Spring Cloud Data Flow to orchestrate all this stuff. And the Spring for Apache Hadoop project supports the major distributions out there. So the Apache Hadoop, and then we also build and distribute jars for that are built against the Cloudera distribution, also against Hortonworks. And Pivotal used to have one, and we built against that as well. So just by defining what distribution you use in your XML POM file, you can actually pull in the right dependencies. You don't have to worry about that. And there's a wiki page on the project. I have links to this in my slides later on, where you can see how to switch. If you, like my examples, use Apache Hadoop. If you want to run against Cloudera, you have to switch to a Cloudera dependency. It's very simple. So let's look at the first demo. It's an ingestion app. So we have a Spring integration stream that's sending messages to us. And it's basically just a text message. And the HDFS writer that I put together will just take that message and persist it in a data file in HDFS. It's a very simple application. If you write something like this, you probably have much more processing in the writer itself or in another processor before there. But I just wanted to keep it really simple. So is that big enough, or should I make it a little bigger? Can you see it? Okay. So what I have here is I'm using this enable binding, which is part of the Spring Cloud Stream project. And I'm basically writing a sync where actually we're just writing data. So we're getting data off this input channel. And the only thing I do is take this HDFS writer and then write out the payload that's coming in. And that is basically my whole program there. So the service activator will make sure that this is the method that gets called for each message, and it will pass in the payload as a string to me. And the data store writer that I have defined up here, I have to configure it, so I have a configuration class that does configure that writer. And it's pretty simple. It uses the Spring for Apache Hadoop data store writer. And it's writing strings, so it's defined here. And I pass in a Hadoop configuration. And since I'm using a boot class from Spring for Apache Hadoop, I get this Hadoop configuration for free based on whatever is in the Spring application context. So I don't even have to set up my connection to Hadoop. And here I create a new text file writer. And I need a base path where it's going to put the data. And then I define my naming strategy. And for this use case, I decide I want to have a fixed name first, and then add in UUID just to make this unique. So if I run it multiple times, I can still write multiple files. And then I just add a file extension. And these are configurable, so I can change that either through passing in Spring properties or changing the application YAML file. And what do I need to get this to work? Do I need a couple of projects? The Spring Data Hadoop boot does give me the startup and the configuration, automatically configuring the Hadoop connection and everything. And then I need the Spring Data Hadoop Store subproject, which is where the actual writer implementation lives. And then I need the Spring Cloud Stream test support for writing my tests, and I need the Spring Cloud Starter stream for the specific binder that I'm going to use. So the default binder I'm using is Kafka, but I also want to be able to run this against Rabbit, so I created a profile. So I can just use a Rabbit profile if I want to create something that will work with Rabbit, or otherwise I'll just end up with something that works for Kafka. And I did write integration tests for this, and I'm using the Spring Boot integration test framework for this. And I set up my Hadoop configuration properties here, and I'm using the file system, local file system, for my Hadoop configuration. That way I can actually inspect the files after my unit test completes. And I'm using a temp directory. And since I know where and then this is actually the test, I write 3 messages. And after everything is done, we need to wait for HDFS to actually close the files, flush it to the file system. So in the after method, I can actually go grab those files and make sure I got my test data in there. So that's an easy way of testing your writers. You don't have to worry about having a live Hadoop cluster running somewhere. And the last part of this test is just booting up this whole application context with a little static test application class. And maybe we should try to run this, see how it works. Try to make this a little bigger here. So here's my data ingest project. And it's just basically a regular Maven project. We saw the POM earlier. Just make sure we build it. So that built the Kafka version since I didn't use the Rabbit partition or the Rabbit profile. So now when I start it up, I can pass in my Hadoop URI, and I already set that in the environment variable, just so I don't have to type that in every time. And I pass in the connection parameters for Kafka as well, since that's where we're going to be reading data from. And I do have a Hadoop running locally on a Vagrant install. And I have links to all this in the slides. So I start up Hadoop repeatedly. So I have this little Vagrant file that just builds it for me. So I can just sit back and not have to rebuild Hadoop every time, run it locally. And I also have a Kafka running in the background here as a Docker file. That didn't work. Didn't like the Kafka. Maybe that doesn't work anymore. That's what happens when you close your laptop. So here I'm starting up a Docker image of Kafka. Just tell him what host I'm on so it will listen on the right host. It's running. So now we should be able to run this. Yeah, it's not happy, huh? make sure I export these things again. They should already be set though. Not happening today. All right, anyway, if this was working, let's try this. Let's try to run this in Cloud Foundry instead. See if we can get that to work. In Cloud Foundry, I do have a Rabbit message broker running. All right, so see if push. Also ingest. So I currently have a local Cloud Foundry running using the PCF dev, which is available from Pivotal Network. And it makes it easier to just test your apps locally. And it runs as a virtual machine. It takes a little while to download and takes a little while to start it up. And once you got it running, it's pretty convenient. So I have to bind my services. And start it up. So while that's starting up, we can start up. I'm going to use Spring Cloud Dataflow to feed some data into my test app. So I just run the shell here, and I'll try to connect that to the Spring Cloud Dataflow server I have running on the Rabbit, or on the Cloud Foundry side. So I do have a Twitter stream running there. So that's what I'm going to try to start up. So I'll just start up a Twitter stream application on Spring Cloud Dataflow, and I'll pipe the data into a demo channel, which I configured my data ingest application to read from. And I just need to deploy this, passing in some deployment properties for my Twitter logging credentials. And I have them in a Twitter properties file. Makes it more convenient. So while that's starting up, we can tail the logs of the data ingest and see if something comes through. Oh, it didn't start. Nothing's working today, huh? Let's try it again. So that one did deploy. All right, let's see what happens. It does look like you might be running now. Oh yeah. So it is processing the data. So let me start that up again. I must have closed that window. Let me destroy the stream that I created. Let me close down this app. And we'll see if we have anything in Hadoop here. I do not. Because it did say processing, but did I not find it? Well, it should have worked, it didn't. All right, so that demo didn't work. Who knows? I'll figure it out. I know it did work earlier, so. Let's see if the next one works. It's data analysis. And we're actually going to take the data I was supposed to write to HDFS and process it and figure out the top hashtags. Because we did take data from Twitter and just feed it into the file. So we should have all the tweet data in a nice Twitter JSON format. So this time I decided to use one of the app starters we have in the Spring Cloud task project. And there's an app starter that takes, runs a Spark task, and we run it on Yarn, so we don't have to worry about setting up a whole Spark cluster environment. So I just copy whatever I download from Spark that comes with a assembly jar that's pretty big. I copy that up to HDFS, then I can reference that in my job, and I don't have to set up a whole Spark environment. It will just run it in Yarn for me. It's very convenient. So my task implementation is basically no code at all, because I'm using the starter, and I'm just accepting what the starter does for me. And the only thing I'm doing is I'm providing some additional, providing some configuration properties. So I don't have to put in a whole long line of configuration properties when I run my job or task. So, because I know for this application, I know exactly where my files are. So I have, this is where the assembly jar is. It's up in HDFS. And my Spark application is a Scala application I wrote a couple of years ago for another demo, and I haven't touched that. It basically just takes the JSON, looks for the text in it, and looks at the hashtags. It's probably not the best algorithm because I get a lot of weird little things there, depending on the hashtags, how they are formatted. But it does serve for like a quick demo. And then I just specify where the input is and where I want my output to go. And the name of the class is the Spark class I wrote years ago in Scala. It's called hashtags. And then I just need to tell Spring where my Hadoop is configured from. So the resource manager, the host, and the port, and the HDFS URI. And again, it's pretty simple dependencies. It's I'm using the Spring Cloud Task app dependencies to get the right versions of everything and in the dependency management, and then I just import the Spring Cloud Starter Task Spark Yarn, which is the name of the starter app. And I had this test dependency. I don't even use it. I couldn't get a test to work with this. And this is what the starter actually looks like. So it's oops. So it just sets up the Yarn environment, the Spark environment to run on Yarn, sets all these parameters, and ships off the thing to execute. And the idea behind these starter apps is that you should be able to use these and then extend them. Now this code is not that easy to extend because it's just one long method. So our next step will be creating a better starter app, so where you can actually break out the methods that for configuring Hadoop, for configuring your Spark environment, whatever, your client. So we have an issue there, so if anybody feels like playing with this, we gladly accept pull requests. So I'm going to wait to run that app a little bit. I just want to go through the next section, which is talking about running this stuff in cloud. And as you can see, it's not that easy to run it on your laptop, so maybe it is easier up in the cloud, even though I couldn't get the Cloud Foundry thing to write to HDFS. So using Hadoop in the cloud, we have lots of different options. You have Amazon Elastic MapReduce was probably one of the first ones out there. And Microsoft has HD Insight. There's Google Cloud, has a Dataproc. IBM has Big Insights. Hortonworks has their Sequence IQ that they acquired. They have this Cloud Break that makes it very easy to deploy Hortonworks HDP to Amazon. Cloudera has their own Amazon and Cloudera Live. And you can roll your own with Docker images or just your own AWS installation if you're adventurous. And all of these have certain things in common. Like Hadoop is very cluster-centric view. Like it really wants you to run things from inside the cluster. And a lot of Hadoop apps wants to have access to the specific configuration files that run in your cluster, like the core site and the yarn site, the XML files. And which is kind of odd because this is like a cluster environment. I want to be able to just tell them, run this, you know your configuration. I don't have to have that in my application environment, but it is what it is. And so you need to have, sometimes you even have to know some internal config settings to get your stuff to run. With Spring for Apache Hadoop, we try to work around this as much as possible. So we create our own Hadoop configuration and with the settings that are absolutely necessary. And most of the time that works. Sometimes we have to add in some extra Hadoop configuration settings, or we can even supply a Hadoop or a core site XML file if we have to. But we do as much as we can behind the scenes there. And also these cloud clusters, when you run Hadoop there, they're configured to run on the internal network in the cloud. So if you're sitting on your laptop, you don't have access to it. So you can't run your app on your laptop, talk to the Hadoop in the cloud without using some kind of a proxy and tunnel and get in that way. So it's easier to run your apps on the same network where the Hadoop cluster is actually running. So with Cloud Foundry, you have to install Hadoop yourself some way, but you can actually link to it using user-provided service. And if you run this on the PCF dev, which is the one I was running on my laptop, you might have to set up some security settings so your Cloud Foundry environment can actually talk to wherever your Hadoop cluster is running on your local machine. I run both on Vagrant, and so they end up in VirtualBox as VMs, so they can actually talk to each other. I just have to open up the security, so the network security, so PCF will let me go talk to these Hadoop services. And then once we create the user-provided service, we can set up your Spring configuration to just point to these VCAP services that are, a boot app will understand this. It will say, okay, you want the VCAP services Hadoop, which is provided to your app in an environment property in a JSON format. And then I set these in the FS default FS, so you can use that from the credentials portion of that. So it makes it easier than if I run this on another cloud installation. I don't have to change my app configuration. I just need to change the user-provided service to point to the right Hadoop that I want to talk to. And I also played around with the Google Cloud Platform, which has now a pretty easy way of creating a Hadoop cluster. You just run a quick command, create a Hadoop demo, tell them the size of your disk and what zone you want it in. So I can target that from any application I deploy using Kubernetes up there. As long as I'm in the same zone, I should be able to access those Hadoop clusters. And one way of providing the connection properties is through a Spring application JSON, which boot understands, and it will set these properties for your Spring application. And this is since I call this Hadoop demo, there will be a master node where the name node runs on. So that's probably the easiest way to get going with Hadoop in the cloud. So maybe I should try to run my little demo app. Do you think we should chance it, see if we can get it to work there? So I have I don't know how many of you are familiar with Kubernetes at all. So I have set up a Kubernetes environment, and Kubernetes runs, I can deploy my apps up in the Google Cloud, and I just, it does deploy in basically what they call pods, which is basically is similar to a couple of virtual machines or Docker images, and I just deploy one Docker image per pod. And then I have, so I already have some stuff running up there. I have Kafka running up there. I have MySQL, and I also have Spring Cloud Dataflow running. So I should be able to run, and if I go look at the, I should have a connection. See, I already ran this earlier, so I have a data file now. So I should be able to point to this data directory and run this little Spark job against that data and get some output. And I already ran the Docker part. Let me make this bigger. So I have a Docker file already in there. I built it and I pushed it up to my Docker repo. And I already copied the files up there too. Let's just make sure they're there. So I have the Spark assembly sitting up there. And I have my Spark hashtags Scala class sitting up there too. So I should actually just be able to what did I call that? I'm in the wrong place here. I'm up in the cloud already. I want to be back on my laptop. So when I work with Kubernetes, I use a kube control command to interact with it. So I can create a pod, or actually this time it's a job. So what that does is this sets up my configuration for Kubernetes. So I want to run my Spark task job. I call it Spark task. I create a cluster, a container, which is a Docker container. This is the name of it that I already uploaded. And I always want to pull the latest version of it. And then I pass in the Spring application JSON to point to wherever my Hadoop things are. And I also have a MySQL pointer there because Spring Cloud Task writes out the results of you executing it into an SQL database. It comes with an embedded database, but I like to be able to see where my jobs ended up. So I just pointed to a persistent MySQL service up in the cloud here. So now I should be able to create this job up there. So now we should see that it has a job, or it has a pod, Spark task, I see it. Actually, let me look at the job and the pods. So now it did deploy a Spark test job, and I have my pod, which is named after the job, and it just adds a couple of characters to make it unique, and it's running. And now it looks like it disappeared. So I can just look at all of them. And we can see we still have that pod here, but it's completed now. So hopefully that means that we actually have some data in Hadoop here. All right, finally, success. So there are the top 10 hashtags based on the data file that I already had up there from my previous test run. So at least we got one thing to work. Pretty good. One out of two. So let's go back to Spring Cloud Data Flow. Now, if the first demo had worked, I would have shown you that actually I can take a stream in Spring Cloud Data Flow, pipe that into a destination, and write the custom app that I put up somewhere in Cloud Foundry or somewhere else, and actually read that data in from the one I did deploy with Spring Cloud Data Flow. So they're interoperable, which makes it very compelling. And Spring Cloud Data Flow lets you register apps. You can either put them in Maven, or if you're using, depending on what flavor of Spring Cloud Data Flow you use, you can deploy on Cloud Foundry, Yarn, Kubernetes, or Mesos. For Kubernetes and Mesos, you have to use Docker images. For Cloud Foundry and Yarn, we use Maven files. So if you put your application in the Maven repository, then you can point the app, Spring Cloud Data Flow, to whatever your Maven repository is and pull it out from there. Or you can use an HTTP link as well. And if you're running on Yarn, you can actually put your apps in HDFS and point to that way. It's basically just a Spring resource abstraction. So whatever is supported by the runtime, it will work. For Kubernetes and Mesos, it has to be a Docker image. And there are a couple of presentations coming up. Actually, there were two of them earlier today. I don't know if you saw them. There was a data microservices in the cloud in this room. And if you didn't, you might want to watch the replay. There was also Task Madness, where the Spring Cloud Task deep dive. If you didn't see that, there'll be replays of all of these. And finally, Thursday, there's an Orchestrate All the Things with Spring Cloud Data Flow presentation that could be interesting. So there are a lot of Spring Cloud Data Flow coverage in this conference. And like I said, we have these starter apps that we're constantly adding to, and they're not part of Spring Cloud Data Flow per se, they're independent. but we have quite a few already ported over. Most of them came from Spring XD, which was the previous iteration of building Spring Cloud data flow type systems. So we have lots of sources, processors, and a couple of tasks. We really need to add more tasks. So right now we only have a couple of Spark things. We're working on some Scoop tasks, so you can run that as a task. So the takeaway from my presentation is that right now it's possible to run your big data apps as cloud-native microservices up in the cloud. And you can run them, same apps locally, and it's very easy to move your app between the different environments. It's all just configuration settings. And the Spring Cloud Stream is basically what makes this possible to actually have these different binder implementations. Right now we have Kafka and we have Rabbit. And there's some others in the works, so that way you can change out what middleware you're using for your messaging. And like you saw, I didn't write any code to go read the stuff from Kafka, because I don't really know how to do that. So I'm relying on the Spring integration and the Spring Kafka team to provide me that. And we also did a little bit of cloud data flow to orchestrate our apps. And we did show that we could write a Spark analysis job to go out and run this. So the demo sources and slides, and if you can get them to work, that'd be great. Up in my GitHub repo, SpringOne 2016. This is the Vagrant Hadoop install I have. So if you want to run a Hadoop cluster on your laptop without spending too much time figuring out how to do it, it's worth a look. And the Spring for Apache Hadoop project link is here. The data flow project link is there. If you have questions, there's always Stack Overflow, or you can ask me now, because I'm here. So, yes?
Does the Spring for Apache Hadoop support Kerberized Hadoop? And if so, what do you need to do to set it up?
What version?
Kerberized.
Oh. So the question was if Spring for Apache Hadoop supports Kerberos and for Hadoop, and yes, it does. So it's basically a configuration options, and I can do that offline. I'm sure we have some docs for that. So yes.
And it also will support a Kerberized or a Kerberos enabled Kafka?
The question is, does it support Kerberized Kafka? I'm not sure about the Kafka part. You might want to go to the Kafka talk tomorrow and ask that question there, because I have no idea. But I'm sure if it doesn't, it will at some point. So.
Thank you.
Any other questions? All right. Well, thanks for coming. Hope you can give the Spring Cloud Data Flow tasks or job or apps a little tryout and report any problems. All right, thanks.